Out there, in the infinite black void between stars, something ancient stirred. Billions of years old, older than our sun itself, it had drifted through the galaxy's cold darkness, silent and unseen, until now. On this December night in 2025, as humanity gazes upward with a mix of awe and dread, 3I/ATLAS is close enough to see clearly. And what the world's most powerful telescopes have revealed is deeply disturbing. Imagine the chill that ran through observatories worldwide when the first spectral data came in. Technicians hunched over screens at the Very Large Telescope in Chile, their faces illuminated by the glow of raw data streams. Spike after spike in the ultraviolet spectrum. Lines that screamed one thing: atomic nickel vapor, Ni, glowing brightly in the comet's expanding coma. But where was the iron? In every comet ever studied, from our own solar system or the previous interstellar visitor 2I/Borisov, nickel and iron appear locked together, forged in the same stellar furnaces, inseparable companions. Here, at 3.88 astronomical units from the sun, far beyond where metals should even vaporize, only nickel showed up. Iron, absent, below detection thresholds, gone. The data was pristine. Bias corrections applied, flat fields calibrated, wavelengths locked with precision. The moving target tracking held steady as 3I/ATLAS raced through the outer solar system. Background sky subtracted, no artifacts, no misidentifications. Cross-checked against every atomic database. NIST, Courage, VALD. It was nickel. Pure isolated nickel vapor. Signal-to-noise ratios soaring above the noise floor. And still, no Phi lines. The same instrument that effortlessly picked up both elements in prior comets found nothing here. The conclusion hit like a cosmic shockwave. This interstellar intruder was releasing nickel alone, in conditions where nature shouldn't allow it. Scientists whispered the words in hushed conference calls, extremely puzzling. Peer-reviewed papers used language reserved for true enigmas. Phrases like extreme properties that send ripples through the community. Reviewers demanded checks for errors, contamination, anything, but the lines held firm. This wasn't a glitch. It was real, and it defied everything we thought we knew about cometary chemistry. Then came the deeper unease. In industrial processes on Earth, pure nickel without iron is commonplace. In alloys, in refining, in human manufacturing. In nature, these metals are born together in supernova explosions, trapped in minerals that resist separation across eons. No known natural mechanism cleanly splits them like this, especially not in the frigid outskirts of a solar system. The anomaly stacked higher, nickel vaporizing at distances where even water ice stays frozen solid. Something was liberating it selectively, violently, against the laws of physics as we understand them. As 3I/ATLAS hurtled closer, the puzzles multiplied. Laboratory models scrambled for explanations. One emerged: nickel carbonyl, NiCO4, a volatile compound so fragile it sublimes at temperatures far below water's freezing point. In Earth's factories, it's used to purify nickel, passing gas over metal to create this ghostly molecule that evaporates easily. Exposed to sunlight, it photolyzes, releasing atomic nickel into the void. Could 3I/ATLAS harbor reservoirs of this compound, trapped in its icy nucleus from some exotic formation environment? Carbon monoxide-rich ices, perhaps, from the coldest depths of another star system? It fit, the threshold at 2.64 astronomical units, where nickel appears first, iron later, as heat ramps up. But even this natural explanation felt strained. No prior comet, solar or interstellar, showed this sequence so dramatically. The mechanism worked in theory, backed by lab volatility tests where nickel carbonyl boils at mere 43 degrees Celsius on Earth and vanishes instantly in vacuum. Yet the rarity gnawed at experts. Why this object alone? Why such purity? The awe of discovery twisted into wonder, laced with fear. What primordial conditions could forge such chemistry? Or was it forged at all? Rewind to the hidden beginnings. Long before official discovery on July 1st, 2025, survey telescopes had glimpsed it unknowingly. Zwicky Transient Facility at Palomar caught faint streaks in June, even late May. TESS, the exoplanet hunter, recorded a persistent glow at 6.4 astronomical units, beyond Jupiter's orbit, where comets should slumber in frozen silence. But 3I/ATLAS was awake, active, outgassing furiously with volatiles more exotic than water, carbon monoxide, carbon dioxide dominating. Amateur sleuths like those poring over ATLAS archives extended the timeline, pixel by pixel, revealing a brightness curve that shouldn't exist so far out. This early activation whispered of hypervolatiles, compounds vaporizing in the feeble sunlight of deep space. Fear crept in. If something this massive, estimated at thousands of times Oumuamua's bulk, was shedding material so aggressively, what else lurked within? The steady glow, night after night, suggested deep reservoirs, not surface frost. A beast stirring from interstellar hibernation, carrying chemistry alien to our system. The global mobilization was frantic. Within weeks, 122 observations from 31 sites flooded the minor planet center. Hubble, JWST, ground giants in Hawaii, Chile, South Africa, all turned skyward. Photometry, spectroscopy, polarimetry poured in, and the anomalies snowballed. At 2.9 astronomical units, water production rates hit 40 kilograms per second, a relentless torrent, unsustainable for most comets at that distance. Mass estimates ballooned, potentially 1,000 times more massive than Oumuamua, a freighter amid pebbles. Encounters this large? Models said once every 10,000 years. Yet here it was, defying rarity. JWST's infrared gaze revealed the killer. Carbon dioxide outgassing 8 times water, a ratio inverting solar system norms. CO2 dominating, suggesting formation in CO-rich voids, or cosmic ray bombardment over billions of years altering surface layers 50 to 65 feet deep. The original chemistry buried, transformed into something processed. Colors shifted ominously, the coma reddening abruptly as if deeper, irradiated organics surged forth. Polarimetry showed extreme negative polarization, dust grains echoing trans-Neptunian objects from our system's frozen fringe. For an interstellar wanderer, this was a haunting echo. Origins in the darkest, coldest recesses. Then the trajectory, a mere 5 degrees inclination to the ecliptic plane, threading planetary orbits like a deliberate path. Odds calculated at 1 in 20,000 for random arrival. Close brushes with Venus, Mars, Jupiter. Statisticians debated post hoc fallacies, but the flatness felt engineered, maximizing solar exposure, awakening its volatiles precisely. Perihelion on October 29, 2025. The spectacle erupted. 7 colossal jets, arcing millions of miles, symmetrical yet sharp-angled, rotating with the nucleus. Mass loss spiking catastrophically. Amateur images captured the violence first. Backyard scopes vindicating citizen science as professionals waited. But then, silence. For 43 agonizing days, official channels went dark. No NASA updates, no briefings amid the wildest outbursts. Social media exploded. 700,000 posts, 40% invoking aliens, cover-ups, signals. Viral threads dissected pixels for machinery. Rumors of hidden data, suppressed findings. The vacuum birthed terror. What were they not saying? November 19th, NASA spoke. Firm, unequivocal. This object is a comet. It looks and behaves like a comet. All evidence points to it being a comet. Reassurance amid speculation, citing orbits, chemistry fitting natural bounds. Yet the statement felt defensive, a wall against the tide. Mainstream voices echoed natural variability expected from alien systems. JWST's 3 scenarios for CO2 dominance. None definitive. Surface cosmic ray scarring, hiding true origins. Consensus careful, admitting unresolved puzzles. But doubts lingered. The nickel-iron split. High methanol in December. ALMA data, 4 times typical, precursors to life's building blocks, aged 7 to 14 billion years, crossing paths with dozens of stars, trajectory improbabilities, sustained activity defying models. As December 19th approaches, closest Earth pass at 270 million kilometers. The final window narrows. Telescopes strain for last spectra, images. Hubble revisits, Psyche tracks, JUICE glimpses, jets post-perihelion. What is 3I/ATLAS truly? A cosmic fluke, enriched in volatiles from another birth? A messenger bearing life's seeds across the galaxy? Or something that stacks too many anomalies? Selective metals like industrial signatures, flat path like guided approach, scale and activity like no natural peer? The fear is palpable. This could be our closest brush with the unknown. Awe at its antiquity, wonder at its chemistry, but disturbing implications. If not natural, what sent it? Why now, as our telescopes finally see? The clock ticks. After December, it recedes forever, accelerating at 150,000 miles per hour into the void. Data archived, questions eternal. Science demands evidence, but the line blurs. What we choose to pursue next, interceptors, deeper probes, may reveal truths we're not ready for. Stare at the sky tonight. 3I/ATLAS is watching back. Close enough now, disturbingly clear. What have we found?